Okay, in this video, I'm going to go over the actual tool path of the part that you see in this picture right here. So we're going to write code, G-code, to mill the part below. We're going to use the following machine parameters. So the tool is a 1/2-inch diameter 4-flute high-speed steel end mill. The spindle speed is 1600 RPM. The plunge rate is 6.4 inches per minute. The feed rate is 19.2 inches per minute. The depth of cut is 0.25 inches. The top of the part is at the 0 plane. And the X0, Y0 is at the bottom left-hand corner. So right where you see this Z, Y, and X, this is X, Y, Z symbol here, that's where the 0 point is for the work offset. Okay, so let's look at a simulation of this part. The part comes along, cuts along this backside of the part, does a radius, and then cuts this straight edge, and then cuts this corner. And you'll see in a moment here that this corner is actually a radial movement. Although you could do this in a straight motion as well, but you end up getting better results if you move in a radial motion around sharp corners. All right, comes down here, does another radial motion around that sharp corner, and then there's that internal corner right there, and then another sharp corner, and then finishes off right there. So we've milled the external profile of this part, and you can see this blue line here was created to as the tool path of this cutter. So you could program it using software like Fusion 360 or GibbsCam or Mastercam, but you can also program it by hand. And so that's what we're going to do in this video. All right, so here we have the part. We have a start and an end point specified. And so the first thing we need to do is, mark where our Z0, X0, and Y0 location is. So that's actually right here. Okay. And so I'm going to start, maybe over here. I'm going to start off the part and then come along here. So that'll be where I'm going to start. So I'm going to call that y is equal to -1.00. That's just going to be off the part in the y direction. So maybe I should specify that too. So the y is going to be going up, and the x is going to go in the horizontal direction. Okay, so the first thing what I like to do is just set out my coordinates. So I'm going to call this point A. So A is equal to, and maybe I'll switch colors here. I'll switch to a blue color here. So A is has a point of x is equal to 0.00, y is equal to -1.000, and z is at -0.250. So I know at this point that the cutter is cutting to a depth of negative of 0.25, so I've already set that up right there, -0.250. All right, and then it's going to move up here. So come along here, and it's going to end up right here. So right at the tangent point of this radius here. Okay, so we're going to go to point B. So point B is equal to x equal to 0.000 and y is equal to, well, let's do a calculation here. So I know that this block is 4 inches, and there's a couple different ways that you could do this, but I'll do the more direct way, the way with the dimensions. So I know that I have this 0.25 here. So I know the cutter comes to 0.25 to this point right here. And then I know that it'll go up 1 inch, and it will go up another 1.5 inches. And then it won't go up another inch, but I'll add in another inch from this dimension right here. And then I'm going to take away 0.5, because this radius here has a radius of 0.5, right? And so that is 0.5. So I'll take away 0.5 inches. Okay, and so what I get here is 3.5. So 1 plus 1.5 is 2.5, plus another 1 is 3.5, minus a 0.5, which brings me to 3. And then I'll add on this 0.25 here. So y will be equal to 3.25. So that's where it ends up, right at the beginning of this arc. Okay, and then it's going to follow this arc around to this point right here. All right, so let's figure out where this point is. This is point C. Point C is, it's moved in the x position 0.5 inches, or it's moved, let's see here, it's moved 1/4 of an inch right here, so it's moved 0.25 inches, and then this point right here in the center of the arc is right where the cutter is, the center of the cutter is, and so this is 0.5, so I know it's moved 0.75 inches. X is equal to the 0.25 step over right here, and the radius. So x is equal to 0.75. And then the y position moved from 3.25, so we have that dimension there, 3.25. And it moved to another 0.5 inches. So moved along there. But I have to draw this diameter accurately, because the center is actually right there. Okay, so this is actually 0.25. Okay, so it's moved 0.5 inches right here, and then another step over, which is 0.25. So that right there. And so I know that it's moved to a position of 4 inches. Okay. All right, so then come back down. Maybe we'll start working off this one. So we have point C right here. Here's my cutter. The center is right there. Nice that this is a 1/2 inch cutter in diameter, because we have a 0.25 inch step over all the way around. So I know that the center of the tool is going to ride along this 4-inch block here. All right. So I'll just put a point here where my G54 work offset is. So this is x equals 0 and y equals 0, just to keep things consistent. Okay, so then this is point C, and the cutter is going to move to point D. All right, right there. Okay, so this one's hopefully an easier one. So this is point D. So D is going to be at going to move in a straight line from this point right here to this point right here. Okay, so this one might be a little bit more challenging to figure out, but I know that this is 0.25 right here, and this is 3.5 to this point, and so and this right here is 0.5 inches. Okay, so if I add up this point here, so 0.25 plus 3.5, so x is equal to, let's do 0.25 plus 3.5. And then I know that the cutter has already moved, it's already at this 0.75. But that doesn't really matter. It's just, it needs to go to a position with respect to the x0 point. So really, it's going to go to x is equal to 0.3, or sorry, 3.75. Okay, and then the y was at 4 inches, and that's just going to remain at 4 inches. Okay. One thing that I didn't do here, and I wish I had, but I want to specify the arc that goes through point B and point C. So point C here. So that's this tool path here, this arc right here in pink. So that arc is going to be basically the radius of the milled part plus half the radius of the cutter. So that arc is, I'll just specify it with R, is equal to 0.5 plus 0.25, and that's equals 0.75. So that's what the R value is going to be in your G code. So just record that whenever you have a tool path along an arc. Okay. So let's take a look at this point right here. Here's point D. Cutter location there, so that's point D. And then I know that I want to, use an arc to go around this sharp corner. And to make a sharp corner, I basically ride around this corner always. So the tool is always in contact with this part. So the tool is going to end up right there. Of course, if I could draw a circle better, I would. But anyway, the circle is going to end up right there. So the midpoint is in line with this line here. And this midpoint is in line with this line here. Okay, and so basically it's going to ride an arc like this. Maybe I'll draw it in pink here. It's going to ride, or purple, it's going to ride this arc right here, and that arc is basically R is equal to 0.25. Okay, so we'll call this point E. So point E the x position was 3.75. And we've just moved down 0.25 inches. So we'll do minus 0.25. And so x is equal to 3.5. And y was at 3.75 inches. Or sorry, y was at 4 inches. Made a mistake here. Let's go back. I was at 3.75 at point D in the x position, and I just moved 0.25 in the x direction. Okay, and you can see that the center of the arc is right on that corner, so the radius is 0.25, which means that this point where it ends up over here is 0.25 inches away in the x direction from that point right there. So 3.75 plus 0.25 is equal to 4.000. Okay, and then we have a y position that was at 4 inches and has just moved down 0.25. It's negative 0.25, and so it equals 3.750. And it moved through a radius of 0.25 inches. Okay, so now we're going to go to point F. So F is going to be right here. So that's a real bad circle. Okay, there we go, a little bit better. Okay, so that's moved down 1 inch, but it has not moved in the x direction at all. So that's an easier one. So F is equal to, or the x is equal to 4 inches. That one hasn't moved in the x direction. And the y is equal to minus 1 inch from where it was. So it was at a position of 3.75 inches from D, or from point E. So it's going to be 1 inch lower than that. So 3.75 minus 1 inch is equal to 2.75. And it's a straight line, so there is no arc. Okay, and then the cutter is going to move to a position right here, just like that. And so it's going to take an arced path. Maybe I'll draw in purple here. It's going to move along an arced path that has a radius of half the cutter. And the cutter is a 0.5 inch cutter, so it's going to be 0.25 inches. So the radius is always half the cutter. So we know that. Okay, and so let's just write which point this is to. So this is point G. So G in the x is now 1/4 of an inch back, so 0.25 inches back. It's actually in line with D, so if we wanted to look at what D was, we could see that. And x is in 3.75 inches. So it was at 4.7 or 4 inches, and it moved back 1/4 of an inch. So this is now at 3.75. That works. Okay, and then the cutter was at point F at 2.75 inches, but it just moved down a quarter of an inch. So 2.75 minus 0.25 is now equal to 2.5 inches. Okay, so I'll draw point G again right here. And then it's going to move, this is point G, it's going to move to point H. And that's an easy motion because it just stays in line. All right. But it moves 1 inch here. So we need to somehow calculate the distance between this line right here and this line right here. So I know at this point right here, because this radius is 0.5 inches, this point right here is 0.5 inches. And so if this total is 1, then I know that between this edge right here, which the cutter is in line with in the x direction, is now 0.5. So 0.5 from this point to this point is 0.5 inches, and I use the radius and this dimension to figure out that dimension right there. So for point H, we know that the x direction at point G was 3.75 inches. But it's just moved back a half an inch. So it's now at 3.25 inches. And the y position didn't actually move at all, so it's still at 2.5 inches. Okay, so then the cutter is going to cut along this edge right there. The cutter is going to end up in line with the tangent point of this straight line to this curved line. That's right here. Okay, and it's going to cut along an arc. And that arc, so I know that this has a radius of 0.25. I know that this half the cutter is 0.25 inches. And this is 0.25 inches. The cutter should actually, I didn't draw this properly, the cutter should be touching the edge there. Okay, so that distance there is half a cutter. And so basically that arc is going to be 0.5 minus 0.25 to this point right here, which is I. Okay, so I is going to move down from the previous x position, 3.25. It's going to move a quarter of an inch. So that's going to end up at x is equal to 3 inches. It's moved a quarter of an inch inwards. Okay, and then it's also moved a quarter of an inch downwards. So y is equal to 2.5 minus 0.25 equals 2.25 inches. All right, and it moves on a radius of r is equal to 0.25. So that radius right there, 0.25. All right. So here's point I right here. And it's going to move to point J. Okay, so it doesn't move in the x direction at all, which is nice, but it does move down, so we need to figure out how much, or where that is, where this point is of j with respect to our 0 point. Okay, so this position right here is 0.5 because of the radius. This has another radius of 0.5 inches. So this dimension right here is 0.5 inches. Okay, and so if this is 0.5 inches and this is 0.5 inches, the 0.5 inches here and 0.5 inches here, and we have a total of 1.5 inches, then that means that the distance between these 2 points here and here, the center points of I and j, is 0.5 inches. Okay, so at point I, we had let's just write j here. So the x point of I was 3 inches, or sorry, the x will not change, so this is going to stay at 3 inches. And then it's going to go, let's just take a picture, look at y. The y point was at 2.25 inches at this point right here. And it's gone down 0.5 inches. So that now equals 1.75 inches. Okay, so now we're going to come to point K. All right, so this is K, and so that's going to ride an arc of 0.25 inches. And we talked about how we know that from this arc right here between these 2 points. So between j and k, we know that the x is going in the positive direction, a quarter of an inch. So here's point k. So k is equal, or has an x position equal to 3 inches. That was the position of j. And it's going to move over 0.25 inches in the positive x direction. So it ends up at 3.25 inches. Then we have a y position that's moved down. So we were at 1.75 inches, and now we're at minus 0.25. Now we're at 1.5 inches. Okay, so let's look at this corner right here. So we were at K here, so here's K. Oh, and I forgot the radius here. I don't want to forget the radius that goes through point J and K. So R is equal to 0.25 inches. Okay, so all right, so we have point K right here. And then we're going to come to point L right here. All right, so this is just a straight line, so it's going to come over in the x direction, and the y direction is going to stay the same. Okay, so this is point L, and so the x direction is equal to, it was at 3.25, and then it's going to move over a half an inch. And I know it's a ½ inch because we already figured it out up here. So between J and H was a ½ inch. So point the same, sort of the same thing, just on the other side of the feature. It's going to move another ½ inch. So plus 0.5 inches. And so that's going to equal 3.75 inches. All right, and my y is going to stay at 1.5 inches. Okay, now we're going to come to point M, which is right here. Okay, and that's going to roll around that corner along an arc of 1/4 inch. So that's half the cutter and half the cutter in this direction here. All right, so that means, and this is point M. Point M is moving over 1/4 inch, so in the x direction, so 3.75 plus 0.25 is equal to 4.0 inches, and then it moves down as well, so y is equal to 1.5 inches minus 0.25 inches, which is equal to 1.25. And there's another way we can check this. Let's look at the overall block again. So we are right here with point M. There's our point M. And I know that in the y position, if this is y0 right here, I know that this is 0.25 inches, and this is 1 inch, so 0.25 plus an inch is 1.25 inches. And so there's a way you can double check your work to make sure that you haven't messed up your math. And so I'm getting a y value of 1.25 inches. So it doesn't appear that my mess is, or my math is messed up. So I'm happy about that. So there we go. Okay, so then we're going to come down to point N. There's point N, and my x position doesn't change at all, which is nice. So I can just keep it at 4 inches. Oh, there's one thing that I forgot here, is to write the arc that is between point L and point M. So R is equal to 0.25 inches. Okay, so then we'll go back to point N here. So point N, the x position doesn't change, but the y position does change, and it changes to 1 inch, of course. So y is equal to 1.25 minus 1. And so that is equal to 0.25 inches with respect to the y0 point. All right. So we're almost done here. Just need to get to point O. All right, and I know that's going to roll around that corner again, so it's going to follow an arc, and that arc is going to have a value of 1/4 inch. And so if it has a radius of 1/4 inch, I know that point O has moved back in the x direction to 3.75. and it's also moved down to the y0 location. It's moved down 1/4 of an inch from 1/4 of an inch, so it is at y is equal to 0. Okay, and of course I'll just write the arc that goes through point N and point O. So that's equal to 0.25 inches. All right, so I'm right here with my cutter at point O, and now I need to go to point P, which is off of the material. I'm going to come along here and come to there. So this is at x is equal to negative 1.00. All right, so this is point P, final point in the tool path here. So P is at x is equal to negative 1.000, and y is equal to 0. All right, and it's a straight line, so it doesn't need a radius value that goes through these 2 points. So that's it right there. Okay, so let's take a look at this code here. So I have a nicer drawing here of the tool going from point A through P all the way around here. Okay, so let's take a look at the code here. So I have a % sign to begin my code. I have a title here starting with the letter O. That's a letter. Okay, I have a couple of items here. I have a G17 right here, so that's saying that I'm cutting in the XY plane. I have a G40, so that's a cutter compensation cancel, a G49, which is a tool length compensation cancel. I have a G80, which is a canned cycle cancel, and then a G9, which is just the absolute zero, or G90, sorry, which is the absolute positioning command. Okay, and then right here I have G20, so it looks like I'm going to be using the inch system. All right, and so I have a bit more code here. I have a G53, so that is the machine coordinate position, and it's telling it to rapid. The G0 here is a rapid motion, and so it's saying for the spindle to go to the 0 position. And it's going to move quickly to that position because I'm using the rapid. Here I'm doing a tool change. So M6 or M06 or M06 is tool change. And I'm going to change to tool 1. All right, and then it says after I've changed to tool 1, it's going to go at 1600 RPM, which was the parameter in the problem. And so this is my spindle speed in RPM right there, and then it's going to say in the clockwise rotation. So MO3 is the clockwise rotation of the cutter, and it's going to rotate at 1600 RPM. Now I'm going to switch to my work offset mode. So all dimensions from here, all positioning from here is with respect to the G54 offset, work offset. And this is something you'd have to do beforehand, and you basically program the machine to have a work offset at this corner right here, which we specified. We actually specified it in the program. So we said that the Z0 is on the top plane and the X0 is along this this edge here along this. That's not a very good color. The x0 is along this plane, and the y0 is along this plane right here. So you would basically position this in the machine, this plate in the machine, to have that as your work offset. Okay, going back to the code here. So, but see these x and y positions? That's with respect to that point, that G54 work offset. All right. Okay, so here we're turning the coolant on. And then we have a rapid motion. So it's going to rapid motion to this x.0 or x0, y -0. And then it's going to rapid position to 0.4 inches above the part. Okay, but we see a G5043 here and an H1. And this is where we are, telling the machine what height of tool to use. So we've already stored that information in the machine, and so a G43 is a tool compensation of tool 1. Okay, and then it says to rapid to 0.2 inches above the part, and here we start to cut. We have a G1, which is a linear interpolation mode, so we're not rapiding to this Z minus 0.25. We are feeding it in at 6.4 inches per minute. Okay, and then we're doing a G1 in the going to 3.25, and we're going to use a speed of 19.2 inches per minute. Okay, so you may be wondering, okay, where are these points? Why is it y 3.25? Well, if you look up here, that y 3.25 point is actually point B. And we calculated that it's at x0 and 3.25. And for point A, we said to go to x0, y equals -1, and z is at -0.25. Okay, well, let's look at where that is in the code. Well, it so happens to be right here. So we're saying to rapid position to x0 and y -1. And then here we're saying, so that's point A, maybe instead of an asterisk, that is point A, and then this is the depth of point A right here, -0.25, and we set a plunge rate to that. Okay, now here's point B. So notice that if x stays the same, I didn't have to write in x0 here. You could, but you don't have to. So you can just show the items that change. So in this case, it changed from, it was at y -1, and now it's at y 3.25. All right, and then here it's going to x point C, which is x is at 0.75 and y is at 4. Okay, and it's moving along a radius of 0.75 inches. This is the end position of point C. All right, so let's go up to our math up here. Let's look at point C. And here, what do you know? We have an x position of 0.75, a y position of 4, and a radius that goes through point B and C of 0.75. And that's exactly what is in the code right here. And we chose a G02 because it's moving in the clockwise position. So from this point to this point right here, you have to move in the clockwise position to get there. All right, so let's skip down. Well, I'm not sure if we have to skip down. I can go line through line. If you want, we're going to do a linear interpolation motion to point D. So this is point D. Then we're going to go to point E. So this is point E right here, and we're not using a linear interpolation motion. We're using a circular interpolation motion in the clockwise direction, which is G02 or G2. Okay, so this is point E. Here's point F right here. And here again is point G. All right, so again, we're using a circular interpolation motion, and we're going to move to this. We're going to end up at this point and this point at point G, and we're going to move through a radius of 0.25. Then we move over to x is equal to 3.25. All right, a linear motion, and then look at this. We have a different G code here. We have G03, so we're going to do a cut in the counterclockwise position at point I to get to point I. All right, and that point is at x 3 inches, y 2.25 inches, and we move on a radius of 0.25 inches. Okay, and then we move to point J, and then we move to point K, which is another counterclockwise path. And we move to this point right here, so that's point K. And then we move to point M, or point L, sorry, move to point L. And then we do a G2, which is a clockwise motion around this corner. So clockwise, all right, and that's point M. And then we move down to point N, and then another clockwise cut to point O. And then finally, we come to point G1 here, point P, okay? And then we do a rapid motion, and we take the tool up from negative 0.25 to 0.4 inches, right there. Okay, and then we turn the spindle off, so spindle off, and then we turn the coolant off. And then we send the spindle home to the 0 point with respect to the machine. So it's a rapid motion right here. It says G0, so it's rapid. And then we rapid to X2. The surface table moves to 2 inches, and then we send it to the Y0 point of the machine. So we're no longer using G54. We're using G53, and then this is the program cancel. And reset command, and then we have right here the final percentage, which is the end of the program. All right, so one thing I want you to notice here is that there were no feed rates for all of these functions right here. No feed rate specified. And that's because they're all going at the last speed, which is here at a feed rate of 19.2 inches per minute. Okay, so this is how you choose your tool path, figure out all your X, Y, Z locations and arcs, radiuses that you go through the center of the cutter, and then write the code to create this part. So this concludes the video on example of writing G code.